This week we're going to be learning about unit circle trigonometry, where we have angles in the coordinate plane. To start off with, let's talk about some key vocabulary. When we have an angle in the coordinate plane, the side of the angle that is, or the ray that's on the positive x-axis is called the initial side. And then if you swing that angle in a counterclockwise direction, you get a positive angle measure, and the other ray is called the terminal side. So a positive angle opens up in the counterclockwise direction, and a negative angle opens up in the clockwise direction. So if we were looking at the angle that started on the x-axis and swung around to quadrant 2, that would be a negative angle. And that's when it moves in the clockwise direction. The vertex of the angle is at the origin. A reference angle is an angle that's less than 90 degrees, and it's an angle formed by the terminal side and the x-axis. So an acute angle, which is less than 90 degrees, formed by the terminal side and the x-axis. So if we look at the example shown here, the reference angle, the x-axis is here. There's our angle. So the acute angle formed by the x-axis and the terminal side, that would be the reference angle. So depending which quadrant the terminal side is in, if the terminal side is in quadrant 1, the reference angle would look like that. In quadrant 2, it would look something like that. In quadrant 3, the reference angle would look like that. And in quadrant 4, it would look like that. So it's always acute, and it's always the terminal side with the x-axis. Okay, quadrantal angles are angles whose terminal side is on the x or y axis. Angles whose terminal side is on the x or y axis. So for example, a 90-degree angle, a 180-degree angle, a 270-degree angle, 360, and so on. Coterminal angles are angles whose terminal side is in the same place. So angles whose terminal side is in the same position. So if you imagine, for example, a 30-degree angle. If I add 30 plus 360, which is a full circle, I would swing around in the positive counterclockwise direction and end up in the exact same place. So 30 plus 360 is 390. That means that 30 and 390 are coterminal angles. So 30, 390. If I added another 360 degrees, I would make another full circle.
Who are you talking to?
I would get 750. So that would also be coterminal. I also could have gone in the negative direction. So say I started at 30 degrees and instead of swinging around in the counterclockwise direction, if I do 30 degrees minus 360, I swing down and around, I would still end up in the same position. So that would be negative 330 degrees. That would also be coterminal with 30, 390, and 750. And there's an infinite number of angles that are coterminal with 360. So if you ever need to find a coterminal angle, you can add 360 degrees or subtract 360 degrees, a full circle. Here are a few examples of drawing an angle in its standard position and giving its reference angle and quadrant. So remember, the quadrants are 1, 2, 3, and 4 in the counterclockwise direction. And if you're drawing a 15-degree angle, remember that a 90-degree angle would be the angle between the x-axis and y-axis in the first quadrant. 15 out of 90 is 1/6. So without using a protractor, if I'm just sort of estimating, I'm going to draw my initial side on the x-axis, and then I want to go 1/6 of the way, swing it up in the direction of the y-axis, and it might look something like that. And that would be my 15-degree angle. Its terminal side lies in quadrant 1, and the reference angle, since this angle is an acute angle formed between its terminal side and the x-axis, its reference angle is itself, 15 degrees. The next one, negative 135, if we subtract 135 minus 90, we have to go another 45 degrees past 90. And remember that we're going in the negative direction. So the initial side is still on the x-axis, but we're swinging down to the left. So if we're going 45 degrees past 90, we're going to the middle of quadrant 3. So we swing down in that direction. And it lands in quadrant 3. Its reference angle is the acute angle formed between the x-axis and the terminal side of the angle. So the reference angle would be this angle right there. Now, if there's 180 degrees that makes up a straight line, 180 minus 135 would be 45. So this angle would have to be 45 degrees. If this is 135, negative 135. But the reference angle is always a positive acute angle, so it's going to be positive 45 degrees. For a 450 degree angle, 450 is 360 plus 90. So we always have our initial side on the x-axis. We make a full circle in the counterclockwise direction, and so that's the 360, and then we go an additional 90 degrees ending on the y-axis. So the terminal side would be right here. So this is actually a quadrantal angle because its terminal side lies on the axis. So it is not in a quadrant, and it doesn't have a reference angle. An angle only has a reference angle if a reference angle has to be an acute angle, so less than 90 degrees. So this doesn't have one. Okay, a little bit of practice with coterminal angles. Listing 3 positive angles that are coterminal to 135. If I subtract 360, I'm not going to get a positive angle. So I'm going to do 135 plus 360, and that gives me 495. I could do another full circle, so 495 plus another 360, and that would give me 855. And then I could add another 360, 855 plus 360 would be 1,215. So 495 degrees, 855 degrees, and 1,215 degrees. And I could keep going all day if I wanted. And then to find 3 negative angles coterminal to 135, we're going to take 135 minus 360 and swing around in the clockwise direction. And we would get negative 225. And if we do negative 225 minus 360, we'll get negative 585, and negative 585 minus 360 would be negative 945. And of course we should not be lazy and put degree symbols with those numbers. And that would be 3 negative angles that are coterminal to 135 degrees. Now we're going to define the 6 trigonometric functions in the coordinate for angles in the coordinate plane. So if we have an angle in the coordinate plane, its initial side is on the x-axis. Here's its terminal side. We could find a right triangle using those rays. And if we have some point on that triangle, we can use the relationships that we defined back when we learned about right triangle trigonometry. So r is going to be the radius, or the distance from the origin to that point. Then we have the x. The horizontal distance is going to be x, and the vertical leg is going to be y. Your angle theta will be the reference angle, the angle between the terminating side and the x-axis. And the opposite side, remember from right triangle trigonometry, is going to be that vertical component. The adjacent side is the horizontal leg, and then r is the hypotenuse of the triangle. Remember SOHCAHTOA. Sine of theta is opposite over hypotenuse, and that gives us y over r. Cosine of theta is adjacent over hypotenuse, which is x over r. Tangent theta is opposite over adjacent, which is y over x. Cosecant theta is the reciprocal of sine. So if we flip the ratio for sine of theta, we get r over y, or the hypotenuse over the opposite. Secant is the reciprocal of cosine, so that's going to be the hypotenuse over the adjacent side, which is r over x, and cotangent theta is the reciprocal of tangent, so the adjacent over the opposite, or x over y. In this example, we're going to evaluate the 6 trigonometric functions for the given angle theta with a point on the terminating side. Now remember that we will always use the reference angle. So the angle we are going to be using is the positive angle formed by the terminal side and the x-axis. So this is our angle, or our triangle right here. The horizontal leg of this triangle is the x value, which is 3. And because it's to the left, we can think of it as -3. The vertical component, the y, is 4, and it's going up, so we think of it as positive. And then if we do Pythagorean theorem, a squared plus b squared equals c squared, -3 squared plus 4 squared equals c squared, we get 9 plus 16 equals c squared, 25 equals c squared. Take the square root of that, and it has to be a positive value. R is always positive. We get c is equal to 5. So that will be the R. So now we're going to evaluate each of the 6 trigonometric functions. Sine of theta is going to be y over r, which is 4 over 5. Cosine theta is x over r, which is -3 over 5, and we do need to keep that negative sign since the x value is negative because it's to the left of the origin. Tangent theta is y over x, which will be 4 over -3. And then cosecant theta is the reciprocal of sine, so I can just take my value for sine theta and flip the fraction, or I could think of it as r over y, which is 5 over 4. Secant theta is the reciprocal of cosine, so I could flip this fraction and get r over x, which is -5 over 3. And cotangent theta is the reciprocal of tangent theta, or x over y, which would be -3/4. Okay, and the last thing, just a little bit of problem solving with the quadrants. So in number 5, it says determine which quadrant and angle theta is in. It should say which quadrant the angle theta is in, because that doesn't make sense. If cosine theta is positive, greater than 0, and cotangent theta is less than 0 or negative. So if we picture the coordinate plane, remember we've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In quadrant 1, both x and y are positive, so positive x, positive y. In quadrant 2, we have a negative x value, but a positive y value. In quadrant 3, they're both negative. And in quadrant 4, we have a positive x and a negative y. So if we are told that cosine theta is positive, that tells us that it's either quadrant 1 or quadrant 4, because those are the places where the x value is greater than 0. But if cotangent is negative, since cotangent is, remember, x over y, we need one of those to be negative. We already know x is positive, so the y value must be negative, which tells us it must be in quadrant 4. Okay, so along the same lines in the next one, find sine theta and tangent theta if cosine theta is 2/3 and cotangent theta is greater than 0. Okay, so if cotangent is positive, and we know cosine is positive because cosine is 2/3, so if they're both positive, we must be talking about, we would need both the x and y coordinate to be positive, so it must be in quadrant 1. So if we have a situation where we've got an angle in quadrant 1, and remember cosine theta is x over r. So for the x, if that's equal to 2/3, we can make r 3, and x 2. Now, if we want to find sine theta, we need y over r, but we don't know y. But we can use the Pythagorean theorem. So using a squared plus b squared equals c squared, we get, remember that a and b need to be the legs. So if I make that y value b, we get 2 squared plus y squared equals 3 squared. And 4 plus y squared equals 9, y squared equals 5, and y would be the square root of 5. So sine theta would be y over r, which is the square root of 5 over 3, and tangent theta is y over x, which would be the square root of 5 over 2.